In this video, I'm going to compare a Ravpower Ace Series RP PV60 battery pack to an Anker Astro E1 model A1211. We're going to take these units apart, take a look at the build quality, and do a full charge and discharge and time the actual performance. Coming right up on Tech Talk. So what we have here is a Ravpower Ace Series external battery pack. We're going to tear this one down and we're going to put it through its paces and take a look at the build quality of this little unit here. So we open up the box. It comes with a little pouch. It comes with the USB and a cute little battery. Let's take a look at the specs for this one. This one's called an RPBP60, and it has a power button, a battery level indicator, a charge port, and a 2.4 amp output. So here's the little unit here. We can get rid of the packaging. We don't need to look at that. What we're interested in is this little unit itself. So there's the power button on the side, which also checks your battery level. And we're going to plug this thing in, and we're going to draw some serious power through this thing. See whether we can break it. So to do this experiment, I've taken myself a USB cord here and I've hacked the end off of it. So we've got bare wires. And we're just going to measure our voltage here. And we should have 5 volts on this thing, which we do. So what we're going to do to test this is I'm going to put my meter in amp mode. This is a 20 amp meter, so I'm putting it on the 20 amp mode. And we'll just use some jumper wires here to connect in some resistors. So we're going to connect our negative lead to one side of the resistor, and we'll connect our positive lead to one side of our amp meter, our ammeter, and then the negative lead we will connect some resistors across, and I'm going to use a 4.7 ohm 1 watt resistor. Under Ohm's law, at 5 volts, a 4.7 ohm resistor should deliver about 1.06 amps of current, but we have to factor in the losses from the test leads, the meter, and the USB cable. So it's going to come out more like about 700 milliamps, I think, of current is what we're going to be able to draw through this. So I'm going to add more resistors to bring up the current. Okay, there we go. So we're drawing actually 0.71 amps right now. We'll add another resistor onto here, and that will bring the current up. There we go. 4.75 volts. That's a little more like it. Now, let's do our short circuit test again. This time we'll get a more accurate read, because I say that was just getting kind of crazy. So we'll just set our timer to 0, and we're going to put a dead short on here, and we're going to time it, and I'm going to let it go for a minute, and we'll see what happens. Okay, we've been going a minute now, so we'll just take the test off here and we'll put it back under its current test, and we'll just let this thing run, and I'm going to see how long it takes to run this battery down, drawing 1.5 amps. Okay, I'm just reconfiguring the way things are hooked up here. Instead of drawing all the current through these leads here, I just paralleled this resistor again to eliminate drawing everything through these 2 leads here. And now we've got the current consumption up to 2.35. So we're maxing this thing out now to see what it will do. I noticed that my alligator clips here are starting to get a bit warm. Everything's getting warm. The resistors are toasty warm here. It's now been going for 55 minutes. And we were drawing about 1.8 amps there for the first, I guess, about 45, 46 minutes. And now I've just, instead of having this resistor just in parallel with these jumpers here, I've just moved it to add some extra capacity because these wires here are not that heavy, so they aren't going to carry a lot of current. These are just cheap jumpers. And while this thing's discharging, I'm trying to figure out the best way to get into this battery. If you notice the voltage meter at this full load, the voltage is dropping a bit. It's dropped to 4.3 volts. If I remove this 1 ohm load, it'll go back up to 4.7. So we are now maxing out the power consumption on this 2.2 amps, and they say it'll do what, 2.4? I think the best way to open this is probably going to be the way I've done it before. Just side cutters into the corner. Ah, there we go. There, it's opening up. There. It's just held together with little clips, little plastic clips. So once we spring them open, we should be able to pop this thing right apart. And of course, they're going to probably break while I do it. So when this thing goes back together, I'm going to have to glue it. But it has cylindrical cells, which is good. There we go. It has cylindrical cells. The little circuit board is attached with some screws, it looks like. What was beeping there? Maybe not. It might just be. Doesn't look like the little circuit board. Doesn't look like the little circuit board is actually screwed down. It's not good. We can just pop this out. See, this thing's still energized. So there we have it. There we have the unit apart, and it's still working. So now we can look at this thing while I'm continuing to discharge it. What I do like is it is cylindrical cells, so it's not the lithium polymer cells are the ones that really get me nervous, because if they're damaged, if they're crushed, or if you poke them with something, well, you'll have a little bit of a meltdown. So here's the LEDs. Here's the circuitry here. Get your little buck converter. Here's your hot as hell inductor, and this is warm. We can actually measure the temperature of this inductor. I'll just get my little meter going here with the external temperature probe while this thing's going. See, that was the whole idea behind this, was I could use this to measure the voltage and monitor the temperature, but we'll just monitor the temperature with this. I'll just power this thing up externally. And here's the temperature probe. We'll measure the temperature of the batteries as the cells are discharging. Now remember, this has been going now for just over an hour. So our battery cell temperature right now is 27 degrees Celsius. 27.5. So nothing critically warm. One thing that is warm on here is the inductor. Watch this. We're drawing a lot of current through that inductor. 2.18 amps to be exact. And as you can see, the temperature of that inductor is over 50 degrees Celsius. I could feel the case getting warm when I was running it there, and well, that's the reason, because the little inductor in there is running pretty warm. Let's check some of the current limiters in here. These chips are running warm too, as you can see. Not really super hot, but they are certainly running around 50 degrees Celsius, as you can see, 51. My resistors here that I'm dumping this current into are also running pretty warm here. If I put the temperature probe in here, cells look to be LG. They're LG GPF1L1865, and then the other number on these is P348L133N. So what I'm going to do when it comes time to charge the battery, this is the temperature of the cells. I've got my temperature sensor, as you can see, just sitting underneath the cells here. It's 25.6, 26 degrees. Once the battery runs down, I have a 2.5 amp USB charger that I'm going to plug in. And what we'll do is we'll disconnect the cells here from the charging board so that I can put the meters on, and we'll actually measure the current that's going into the cells. I measure the voltage that the cells are being charged at, and we'll monitor the temperature while this is charging up. And that should complete our little test here of this unit, and then we'll compare it to the other one that's coming. Okay, there we go. It just shut down. Went for 2 hours and 17 minutes. And the cell temperature peaked out at 28.5. Next thing we're going to do now is I'm going to actually take off this lead here so that I can clip my, or actually I probably just unsoldered it right here at the back, so I can clip my ammeter on here so that we can monitor the current and we'll get this thing charging. Okay, I've got my meter now connected. This is just the voltmeter here, and I'm just going to get my ammeter. So I'm just going to rejig things here. And we'll connect the ammeter across the, I don't know which way I'm going here. I'll find out pretty quick whether it says positive or negative. Okay, let's connect this up here. We'll see that the charging voltage is 3.2, and it's charging at 0.8 amps, or 800 milliamp. And now we'll just let this thing charge, and we'll monitor this, and again we'll, well, I mean, there's no point in me timing this because this is going to take overnight to charge. I'm just going to get my temperature probe here, and we'll put the temperature probe onto the battery so that we can monitor the charge temperature of the cells. There we go. Okay, now we'll monitor the charge temperature and we'll monitor the voltage as the cells charge up. Okay, about 1 hour into the charge, our charging voltage is now 3.459 and our charge current has dropped down to 0.59, so 590 milliamps, 0.59 of an amp. Our cell temperature has dropped to 23.2 degrees Celsius. It's been about 3.5 hours on charge now. As you can see, the cell temperature has now risen to 20.1 degrees, and the cells are probably getting close to being fully charged. We're at 3.659 volts, and the current is now 430 milliamps to charge. So the cells are probably getting close to being fully charged. Okay, it's probably been about 4 hours now, and as you can see, I've had the camera running here, so this is cut down substantially. The cells are going to go to 0 now that the cells are fully charged. Let's discharge. I had wanted to monitor the current from the cell and monitor the voltage from the cell. The problem was the protection circuit on this unit is so sensitive that just running the negative terminal from the battery through the shunt in the ammeter and then connecting it to the black wire here, as soon as I put any type of load, any type of serious load on the output, it immediately shut down. I could plug my phone in and charge it, that would work, but I couldn't put a load on like my resistive load that I wanted to do. So I've just reconnected this up. This is actually monitoring the output current, but instead of looking at the voltage from the actual inverter, we're now looking at the cell voltage. So the cells are now at 3.8 volts and we're supplying 2.38 amps of current. So we're almost at the limit of this unit. As we can see, the actual cell voltage is starting to slowly come down now. The key will be what voltage do the cells get to when it actually shuts down completely. Right now we've still got 4 bars showing on the charge meter here. Just for fun, I've now just reconnected the temperature probe. I'm actually powering this up from the USB, so if I put this into cycle mode, it's now showing 4.2 volts coming out of the inverter. So I can measure the voltage here and the temperature and the time, of course. It'll cycle now between the cell temperature and the voltage and the time. It's been going now for about 10 minutes, so we'll have a record of how long it's gone for using this little module. So at this point, I'm just going to leave the camera recording this, and we'll time lapse this just so that we get the full shutdown on camera. Now it was about 2:20 when I first started this test. As you can see, we're almost at the shutdown point. It is now 15:48, and this is under full load. It's down to 1.96 amp. There it goes. That's it. That's it. Complete discharge. Cell voltage down to 3.08 volts. The unit is completely shut down now. Now we're going to do the same test with the Anker brand of battery backup. But what I found with the Anker is it's only rated at 2 amps. So we're going to redo this test when I finish that one and give it a fair timed discharge under the same load, which is going to be about 1.9 amps. So this one's the Anker Astro E1. Its model is A1211, and it's a 2 amp output. It's rated at 5200 milliamp hours, or 19.24 watt hours, whereas the Ravpower that we just looked at was rated at 6700 milliamp hours, or 24.79 watt hours. Not fully charged. We'll charge it and then we'll do the test. As soon as I load this down, it should come up to 5 volts, which it has, and you can see we're drawing 1.5 amps through here. And I'm going to add another current draw here. We're going to hook another 1 ohm resistor, and we're going to hook that back up to the meter here. So that's going to draw 2 amps. And we're going to see what happens here. Okay, my test is already going sideways, as this is only a 2 amp rated power pack, and the other one was a 2.4, which is going to skew my results. So we'll just monitor this as the battery goes down, and then what we're going to do is we're going to crack this open once it's dead, and we'll recharge it, and I'll monitor the cell temperature and stuff as it recharges. Tried and true method. Let's see whether we can pry this thing open. There it goes. There we go. Okay, let's take a look at what's inside this thing. So here are our 2 cells. There are 2 cells in parallel. Here's the strip going up to the board. Here's our little board here. It's got one little capacitor on here, a couple of ICs. You're going to have the, I'm sure these are probably the battery protection ICs here. Let's take a closer look. what these are. (2418E). And as you can see, one light's flashing because the battery is totally dead. So what I want to do is I want to check the charge current on this thing. So we'll do that by unsoldering one of the tabs here so that we can hook up the meter to it, and we can plug it in and we can actually monitor how many milliamps are going to charge this thing, and then we'll let it charge up. We'll measure the cell voltages too. Okay, we're now charging, and I'm going to just add my voltage meter here, and we'll monitor the cell voltage. And I'm also going to hook up the temperature probe here, and we'll monitor the cell temperature as it charges. Okay, we're charging at 4.18 volts. Charging at looks like half an amp, just over half an amp, 550 milliamps is what it is charging at. And the only thing left to connect is the temperature monitor. We're just going to take the temperature probe here, and I'll just slide it in here to the between the cells, and that way we can monitor the cell temperature. And this is going to cycle between the temperature and the voltage. And we've got our current monitoring here, and we're going to let this charge up and see how long it takes to charge and monitor the cell temperature while we're doing it. Okay, the cells are now fully charged, and as you can see, the current is down to 180 milliamps. So we're now at a full charge. I'm going to unplug this thing now, and now we can go into the discharge cycle. So I'm just going to set up my jig here so that we can discharge this at the full output, and we'll monitor the cell temperature and we'll time it and see how long it goes. And so we're going to leave that going, and we're going to let this run, and we'll monitor the cell temperature. I can actually monitor other things on here too, like such as the IC temperature and stuff if I needed to. We know that the inductor is going to get hot, but I think most importantly we just want to monitor the cell temperature. So I'm going to stuff that in there. This will monitor the cell temperature, and we're going to see how long this thing runs before it shuts off. Obviously I'm not going to leave the camera run the whole time here, but we'll monitor it. And I might even be drawing a little bit too much power because I see my voltage has dropped down to 3.9 on this one. So this one's only rated at 2 amps. So let's just try and run this down a little bit so that I'm not going to draw more than 2 amps through here. Running 1.6 amps now, 2.05. I'm actually biasing the test now because I was going to try and run everything equal, but you know the problem is the other battery pack was rated at 2.4 amps. So this one's only rated at 2 amps. So I'm going to try and get my consumption down because this is going to limit it at 2.04. So I just want to try and get my consumption close to 2 amps. There we go. So we're running a 1 ohm resistor and a 4.7 ohm resistor in parallel. I'm going to run it at 1.9. There we go. This is maxing out this thing. Now our voltage is back because this Anker power battery is only rated at 2 amps, and the Ravpower that we've also compared is rated at 2.4. So that was the difference. So maybe what I'll do is once we've discharged this one completely, I will bring the Ravpower back. It is now fully charged, and I'll bring the Ravpower back and I'll just do a current discharge. I won't tear it apart again because we've done the cell checkout on that, but we'll bring that one back and I'll time that one on the same load as this, on a 1.98 amp load, and we'll see how much longer it runs because it should run longer. It's a higher capacity battery than this one. Anyway, let's see how long this one goes. I'll shut the camera off now. I'll turn it on and off intermittently as the discharge cycle continues, and we'll see exactly how long this thing runs before it shuts down. 21 minutes in, I had to change my configuration. 22 minutes in now, I had to change my configuration because my battery voltage has already dropped below 3.5 volts, which is the minimum for this display. So this one went out. So I've just reconfigured. So now this one is showing my output voltage and the cell temperature, which has now gone up to 28 degrees. The cells are starting to heat up. My output voltage is still 4.7 volts, but my cell voltage is down to 3.46. So the cells are discharging quite nicely here. We'll just continue to monitor this as the cells continue to drop. And getting the other pack ready to put in here once this one goes down so we can time the Ravpower. See how long it will run under the same conditions, because the test I did on this one, I had this one under a higher load. So I want to do a comparison of the Ravpower using the same discharge jig that I'm using here with the same current. So I've got the battery pack here ready to go. Once this one discharges, we'll reset the timer and we'll discharge under the same conditions. I just witnessed it go off. 1 hour and 7 minutes. The cell voltage just dropped down, and we saw the temperature rise on the battery. That's it. That's all this one does. Let's hook up the Ravpower to the same jig, and we'll run that and see how long it goes, and I'll reset the time on this one. Now I won't be monitoring the cell on the Ravpower just because it is it's all back together. So I'm just going to I guess I can leave this on here as well. This meter just won't show anything. Or we can, yeah, it doesn't matter. Do it all in one sweep here so that you can see that I haven't edited anything. So everything's going to stay exactly the same. We're just going to plug this one in, and we're going to start the time clock running again here. We're drawing 1.93 amps, and we're going to let this one run until it drops. See how long this one will go for. So this is now going to be a continuous camera shot because I'm not about to wait around here for this to go. So we're going to time lapse this so you can see it go by real quick here. This is going to go out. Okay, so that's going to time out. We know that we're drawing 1.9 amps. It will continue to draw 1.9 amps after the display has gone out, for sure. For that matter, I can even I can add this one as well, just to the mix, so that because this display is going to go out once it dies. This display is going to go out, but this one here, this one will continue to show the voltage. Let's reset that one now for another couple minutes. See, they're both showing 4.6 volts, so we know the voltage is correct on here. But this one will actually show the idle voltage, which should drop to 0 when it goes out. But we've got the running clock here, so I'm going to restart my camera here so a new file is started so that I can just time lapse this quickly, and then I'm going to go out and have lunch while this thing is going, because as you can see from the time, it's 12 o'clock. Well, that's it. It just shut down. 2 hours and 3 minutes running the identical discharge setup that we used on the Anker, which only ran for 1 hour and 7 minutes. I think that answers the question as to which one of these two devices has more storage power and more charging power. Hope you enjoyed this video, and we'll catch you in the next one.